that the secant of theta is one of the cosine of theta, and the cosecant of theta and the cotangent of theta is one over the tangent. And that the sine squared theta plus the cosine squared theta is 1, and that the tangent squared theta plus 1 is equal to the secant squared theta, and that the cotangent squared theta plus 1 is equal to the cosecant squared theta. That the derivative of the sine is the cosine, and that the derivative of the cosine is the minus the sine, and that the derivative of the tangent is the secant squared. Well, this will be a review in the beginning of the semester, right? And that the derivative of the secant is what? Is the secant times the tangent. We also saw the, what formulas? Some different formulas. The cosine of A plus B is the cosine of A cosine of B minus the sine of A sine of B. And that the cosine of A minus B is the cosine of A times the cosine of B plus the sine of A times the sine of B. And that the sine of A plus B is the sine of A times the cosine of B plus the cosine of A times the sine of B. Then the sine of A minus B is the sine of A times the cosine of B minus the cosine of A times the sine of B. And that if you use A is equal to B, then the cosine of 2A is equal to the cosine squared of A minus the sine squared of A. And then, but if you do the fact that the cosine squared is 1 minus sine squared, and this is 1 minus 2 sine squared, the cosine of 2A is 1 minus 2 sine squared A. And if you use the fact that the sine squared of A is 1 minus cosine squared A, this becomes 2 cosine squared A minus 1. The cosine of 2A is 2 cosine squared A minus 1. And you can rewrite these as half angle formulas, or that is to say, if you just do some algebra. And you know that if cosine 2A is 1 minus 2 sine squared A, then 1 minus cosine 2A divided by 2 is the sine squared of A. So that's a nice formula. Sine squared of A is 1 minus the cosine of 2A over 2. And then if you add 1 plus the cosine of 2A, you will get 2 cosine squared A. Then you divide by 2, you will get the cosine squared of A. So the cosine squared of A is equal to the cosine of 2A plus 1 over 2. This is a very important formula. Now, these formulas here, if you add them up, if you add the cosine of A plus B with the cosine of A minus B, that is to say, on the left-hand side you will add these, and on the right-hand side you will add these. On the left-hand side you will add these, you will get the cosine of A plus B plus the cosine of A minus B is equal to what? Well, if you add these, you will get 0. And if you add these, you will get 2 cosine A cosine B. 2 cosine A cosine B. That is to say, the cosine of A times the cosine of B is half of this. Okay, this is my very quick review. Pre-calculus for you. Now, if you do this, subtract this. This subtract this, you'll get cosine A minus B minus cosine of A plus B. Cosine of A minus B minus the cosine of A plus B. And if you do this, subtract this, you will get 0. And this subtract this will be 2 sine A sine B. 2 sine A sine B. Yeah. That is to say, the sine of A times the sine of B is the cosine of A minus B minus the cosine of A plus B divided by 2. Now, if you do this plus this plus this, that is to say sine A plus B, plus sine A minus B, then you will get this plus this and this plus this. Well, this plus this will be 0. And then you will have sine A cosine B plus sine A cosine B, two of them. 2 sine A cosine B. 2 sine A cosine B. That is to say, the sine of A times the cosine of B is half of this. And we call these the product to sum formulas. That is to say, how to convert a product of a two trigonometric function into a sum of two trigonometric functions. Okay, you should all have seen these in calculus. Miss! Yes, Mina, did you see such a thing in calculus, pre-calculus? You had a good pre-calculus. Now, these formulas here are very, very important. And these formulas here are quite important. That is to say, if you want to integrate something like this, I'll talk about this later on. If you want to integrate something like this, cosine 3x times the sine of 5x, anybody know how to integrate this? No. So what you'll do is you'll rewrite it like this. Sine of 8x, which is easy to integrate, plus the sine of negative 2x, which is easy to integrate. But this is not. So whenever you have some trig, you want to have to, if you have a trig, if you have the integral, you have to do some trig tricks. Trig tricks. That's just how you get out of this nonsense. Likewise, anybody know what this is? No, probably not. But you will say, well, hey, why don't you write like this? This will say what? The cosine of 2x plus 1 over 2. And who doesn't know how to integrate this? Go to calculus 1, friends. So whenever you have some trig things and they are difficult, you may have to do some trig tricks. Like here. There's one more thing I want to review about trigonometry. In some senses, this is probably the most important thing. How to make a triangle. How to make a triangle. Very, very important. You must know how to make triangles. If you do not know how to make triangles, in some sense, you don't know what trigonometry is. Yes. I'm talking about the right angle triangles. Triangles with 90 degrees, which is the basis of trigonometry. So, anybody know what is the secant of the angle whose tangent is 3 over x? Anybody know? Ms. Yasmina, you had a good pre-calculus professor. You want to take a stab at it? The secant of the angle whose tangent is 3 over x. Now, you remember where we are in the grand scheme of things. We are on what trig now? Integration, what number?
5.
5. Right? Number 5, we are integration. Integration tricks. Integration tricks. And we are on number 5, which is to say trigonometric integrals. And, well, so what I said, something like this. Which you have not learned in calculus 1. I don't care how good a calculus 1 professor you had, Ms. Yasmina, he probably didn't teach you this. Right? Now, trigonometric integrals and, so that would be this. Integrals involving the use of trigonometric substitutions, which is a different thing. We'll talk about that later on today. Substitution. Something like this. Integral of the square root of 1 plus 4x squared, which you would have seen on the test, which is why you have to do it by the midpoint rule, because nobody knows how to integrate this yet. But you say to yourself, well, surely there must be a way to integrate this thing. And the answer is yes. It involves trigonometry. You say to yourself, where's the trigonometry there? But it happens that you can't do this using trigonometry. We'll talk. So, in this particular instance, you must know how to make a triangle. You must know how to make a triangle. Ms. Yasmina, what is the secant of the angle whose tangent is 3 over x? Do you know? Do you not know, Ms. Yasmina? You don't know? No. The answer is the square root of 9 plus x squared over x. Anybody know how I got that? Because I will make a triangle. I say I want the secant of what?
Tangent of 3 of x.
I want the secant of an angle. This is an angle. I want the secant of theta. That is what I want.